Hey guys, welcome to my YouTube channel. So today we'll be solving Lead Code Weekly Contest 368 problems 1 and 2. Okay, but before starting, I have a small announcement to make. I'll be available on Calendly. You can book a slot with me, and that will be entirely free, no charges. So whatever you want to discuss, whether it's your interview preparation or resume reviewing, everything we can do in that call. Feel free to schedule an appointment. Okay, cool. Now let's move to the question. Okay. So what question says is you are given a zero index array nums and that will consist integers. We have to find a triplet ijk such that the value of j is greater than value of at I and same value at j is greater than value at k. Okay. Now what we have to return is, so let's say if we find some elements in such a way, then we have to return what will be the sum possible. Let's say we find three elements. Sorry, let's say find something like this: 2, 3, and 5, and some like let's say 2, 7, and 8. So what we need to do is these are the indices, right? These are the indices. Okay, so we are talking about indices. So what we'll do, we'll take the sum at this value, sorry, this indices, some of the values at this indices. So let's say here it was 3, it was 4, and it was uh, 2 again. And let's say it was 3, let's say it was 7, and it's a 2 again. Or like let's say 1 again, something like that. So the sum here will be 3 plus 4 plus 2. That will be 7 plus 2, 9. And this will be 3 plus 7, that is 10 plus 1, that will be 11. So we know that this both of these are mountain triplets, but we have to return the minimum sum. And here we can see it is 9, so we'll be returning 9. I hope the question will be clear. Now, the only difference between the first and second question is between the constraint. In the first question, you can see the length is only 10, sorry, 50. And in second question, we have length as 10 to the power 5. Now, let's go for brute force solution. What brute force solution would look like? So let's say if I have an array. So what I will do, I'll select element. For all the element behind this, I'll check all the elements after this. So let's say I'll select this element and I'll check if this element is greater than, sorry, less than this element. Okay, so what we need to do, if it's the position I, so for all the position at left, we'll check if this is the position which is less than I, so less than the value at position I. Similarly, we'll check what is the position of the element which is less than the value of I, and we will just take the sum, like what will be the sum of this and this and this. So let's say this one and this one, these are the two indices which are at which the value is lesser than the value at index I. And similarly, here are three positions. Let's say this one and let mark one position. So in the brute force solution, what we can do is we can run a loop for this I, then we can figure out this one, and this one, and then we can take the sum. But that will be completely brute force approach. But let's say if I have a number 5 and there are two numbers which is smaller than this in its left, and two numbers or let's say three numbers in the right which are smaller than this 5. Then for this 5, let's say if we are considering this mountain element, so okay, let me just give you one hint or one approach. So next time whenever you see na that we are talking about triplets, more or less you can try selecting the middle element first, and then we can pick the sideways elements. Okay, so we'll follow the same approach over here. So let's say if I am picking the middle element as 5, now I know that I can pick some element x which should be less than 5, and similarly 5 should be greater than some element, let's say y. And one more condition we have is x plus 5 plus y should be as minimum as possible. For that, what we can do is 5 is fixed, so we can decrease x or take x as minimum as possible and y as minimum as possible. So seeing this, what we can realize over here is we have to minimize x and minimize y. That's simple then, na, right? Like if we take the minimum x possible in the left, that is 2, and minimum y possible in the right, that is, sorry, 1, this one. Then our sum will be 2 plus 5 plus 1, that will be 8. Okay. Now we can similarly consider for, like, let's start this from the beginning. So how it will look like: 2, 3, 5. What was the array? 4, 1, 3. So let's say what we can say is we will start for 2. We have no elements. right? We have no elements for 2, right? In the left, so we can't take 2. We will check for 3. In the 3, we have one smaller element, that is 2. And in the right, we have the smallest element, that is less than 3, is 1. So for this 3, we will have sub 3 plus 2 plus 1. Okay. Similarly, we'll check for 5. What is the minimum possible element in the left and in the right? So if we'll see for 5, we again go for 2 and again go for in the right, again go for 1. So what we are realizing that if we are moving from this way, we need what was the minimum element in this left side. That will be the minimum element, right? Because for the 5, out of all the elements in the left, we have to find the smallest element, and if that smallest element is greater than 5, then we can't take this 5 as the middle element. Similarly, we will calculate all the minimum element from the right, and if that minimum element is greater than 5, again we can't take it. But if we have condition that we have 5 and some smaller element in the left side and some smaller element in the right side, then it can be our one of the answer. So for each indices from 1 to n minus 2, because we need one element in the left, right, so minimum at least one element in the left, and similarly in one element will be in the right, that can be n minus 1th position. So we get for all the indices between 1 to n minus 2, we'll just check if we satisfy the condition. What is the will be the condition? That nums of I should be greater than, we storing the left minimum in left array, so should be greater than left of I. Okay. And nums of I, sorry, nums of I should be greater than right of I. Okay. Then in this scenario, nums of I plus left of I plus right of I will be all one possible sum. Okay. And now for calculating left of I, we know that we can simply start left of 0 as nums of 0, because we have to calculate what we have to calculate. If you remember that at ith position, what will be the minimum value present on its left side, right? So left of I we can simply write as nums of 0, and then we can for run a loop for int I is equals to 1 to I less than n, I plus plus. And what will be the condition? First of all, we for ith position, we needed to calculate the minimum element on its left, and we won't be including this I. So we can simply write like left of I, and we'll have one variable, sorry, not left of I, sorry, it will be mx, or let's say minimum, min element mn. Then we can simply write left of I is equals to mn, and then we can similarly update mn as mn is equal to minimum of mn, comma, whatever the value we have at nums of I. So in this scenario, what we'll have for all the elements, we'll have the smallest element in their left. Similarly, if we'll reverse the loop from like n minus 1 to 0, we can have elements at our right. We will have some base condition, like we won't be checking. Just give me a second. So we'll have base condition that we'll start from 1, and if we are seeing, we are just doing the same, sorry, here. So we are what we have one variable ml that will represent the minimum element till current position, left till current position, okay, or before current position, that will be nums of 0. And similarly for the right position, we have nums of I. Now if we'll see, I have left of I is equals to first of all ml, and then I updated ml to whatever the minimum value, whether it's the previous one, that is ml, or nums of I. Similarly for right, I have running the same loop. If we'll see it, first of all was 1, so it will become n minus 2. When I will becomes 2, it will become n minus 3. So we are traversing from right to left, if we'll see, and we are doing the same thing. And finally we'll run from loop from 1 to n minus 2. Okay. And we'll check the condition. If the condition satisfies, then we will update our answer, and we'll finally submit it. Okay, let's try submitting the solution. It's an essay solution. If we look at the first problem, we can give the same solution, or we can write the brute force one. Everything will be accepted over here. So passing the same solution also will have our answer accepted. Okay, let me know if you guys have any question on the doubt, and remember to you can connect me on Calendly. So just schedule a slot. Okay, thank you guys.